Okay, so you have to wonder, what on earth does a giant 450-foot wooden arc have to do with solving for x in algebra? Well, today we're going to deconstruct this fascinating and, let's be real, pretty unusual math lesson that does exactly that. It uses the story of Noah's Ark to teach algebra. So let's dive right in. I mean, that's the big question, right? How in the world do you connect this ancient, epic story about a flood and a boat full of animals with the abstract world of algebra? It seems like two totally different universes. But, as we're about to find out, the whole thing hinges on one key idea: following instructions with absolute precision. So this is the lesson's official objective, right here. The whole point isn't just to solve equations and inequalities. Nope. It's about framing that entire process through the story of Noah, who had to meticulously follow every single one of God's commands. It's a creative attempt to take something abstract like math and anchor it in a really solid, concrete story. All right, so let's get into the heart of the lesson itself. We're going to walk through the exact examples these students are given, kicking things off with some of the, practical problems Noah supposedly ran into while he was building that famous ark. Okay, here's our first word problem. It's all about the ark's support beams. So, the story goes, Noah built 6 sections. Each of those sections needed a certain number of beams, specifically 3x plus 4 beams. We don't know what x is yet, but we do know he used 180 beams in total. So the puzzle is, what's the value of x? And right there, that's the first big skill this lesson is teaching: how to translate a story into pure math. You've got your 6 sections, you multiply that by the number of beams in each section, and it all equals the total of 180. Boom! It's a clean, simple equation just waiting to be solved. Now, solving this is a pretty standard 3-step deal. First, you've got to distribute that 6 across the parentheses. Then, your goal is to get that x term all by itself. And finally, you just divide to find out what x is equal to. And for the final step, you have to do the reverse translation. Take that number and put it back into the story. The answer, 8.67, basically means Noah was using about 9 beams for the main structure of each section before he added any extras. And just like that, problem number 1 is done. All right, the next problem throws in a new twist. We're talking about animal food now. But you got to pay really close attention to the wording here. The phrase is more than, and that's a huge clue that we're not dealing with a simple equation anymore. We're moving into the world of inequalities. So when you translate that problem, you get this inequality. And here's the big difference, right? This isn't about finding one single exact answer for x. It's about setting a limit, a boundary. The total food they need has to be less than the 98 units they have on hand. The actual process for solving this is almost exactly the same as the last problem. You distribute the number, get the x term by itself, and then divide. Simple as that. And that gives you your final boundary. So see, our final answer isn't just one number. It's a rule. To make sure there's enough food, x can be any number at all as long as it's less than 17. And that really drives home the whole point of what makes an inequality different from an equation. Okay, get ready, because this final example really cranks up the difficulty. This one is all about calculating wood usage, and the formula, whoa. It's got multiple layers of grouping symbols. We're talking brackets and parentheses, plus an exponent thrown in for good measure. Yeah. This equation definitely looks more intimidating, and for good reason. With parentheses, brackets, and an exponent all jumbled in there, following the order of operations isn't just a good idea, it is absolutely critical. This is really where that theme of precision gets put to the test. To crack this thing, you basically have to work from the outside in. It's like peeling an onion. You peel back each layer one at a time. Then the division, then the subtraction, then the exponents, until you finally get x all by itself. And when you do all that, you end up with a value of about 5.21. And one more time, we translate that math answer back into the story. So an x value of roughly 5.21 means that, according to this specific formula, Noah used a little over 5 units of wood for each section. So after the lesson walks students through those examples, it shifts gears. It's time to reinforce everything with some independent practice because, that's how you really make these skills stick. And this homework section really shows you everything the lesson is trying to cover. It actually moves beyond the whole Noah's Ark story and gets into all sorts of stuff. Different types of equations, writing inequalities from scratch, and even drawing the solutions on a number line. It's really meant to be a full, comprehensive review. Let's just pull out one specific example here. This is a classic kind of word problem where you have to read so carefully. The students have to figure out how to take phrases like the difference of or is no more than and turn them into actual math symbols. And there it is. That's how that whole sentence gets translated into the language of math. Every single part has a direct counterpart. 4 times, the difference of, and that really important phrase, no more than, which becomes less than or equal to. Nailing this kind of translation is, it's a fundamental skill in algebra. Okay, so after all the numbers and equations and inequalities, what's the big takeaway? What's the final point of all this? Well, this is where the lesson circles all the way back and ties the 2 big themes, Noah's Ark and algebra, together for the grand finale. The entire lesson wraps up with this one Bible verse from Genesis. This quote is basically the anchor for the whole teaching method. It's all about Noah's complete, total, and exact obedience to the instructions he was given. And that brings us to the core message, the whole point of this entire lesson. The argument it's making is that solving a math equation is really an exercise in faithful precision. See the connection? Just like Noah couldn't just, wing it or deviate from God's blueprint for the ark, a student can't just skip a step or ignore the order of operations. So, in this context, math becomes a lesson in being methodical and careful. So there you have it. That's our breakdown of a truly unique approach to teaching math. Whether you think it's effective or maybe just a little odd, it definitely makes you think, right? Which brings us to a final question for you. What's the most unusual or creative way a topic has ever been explained to you? I'd be really curious to hear about it.